Hey there, kiddos. Here is your video on evaluating functions, which is nothing more than plugging in a number and using it to get an answer. So new definitions. Function notation is the first one. There's a big long definition that goes with it. Here's what you need to know. Function notation looks like this. It's pronounced f of x, and it is the same thing as y. It just replaces the y in an equation. So instead of y, we put f of x. To find f of x, all we have to do is plug in the value of x into our equation everywhere we see an x and then do what it asks. So your first example, we want to evaluate that function f of x equals 4x minus 3, and they tell us that when the domain is -1, 0, and 2. So they tell us the domain, and if you'll go back a couple days and remember, domain is the x value, so they're telling you x is -1, 0, and 2. So we're going to plug it in. We're going to do this 3 times. So the first thing we're going to do is find f of -1. That means we're going to plug -1 in over here, so we're going to do 4 times -1 minus 3. This f of -1 is just a notation. You don't have to do anything with it. It's just saying the function value when x is -1. That's all it means. You don't have to do anything. On the right hand side though, we'll plug that in our calculator or into your head, however you want to do it. 4 times -1 minus 3, and you should get -7. And so the value of that function when x is -1 is -7. So we'll do it again when x is 0. So we find f of 0. So we plug in 4 times 0 minus 3. Well, 4 times 0 is 0, and 0 minus 3 is -3. So there's your next value. And then we'll do it once more for 2. So we'll do f of 2. 4 times 2 minus 3. And 4 times 2 is 8. 8 minus 3 is 5. So there are your 3 values, -7, -3, and 5. So I'm going to go out of order here just slightly from what you have on your notes. I'm skipping ahead to questions 3, 4, 5, and 6, and then we'll come back to that number 2 that has the big old graph on it. I want to practice evaluating before we look at the graph. So if you look at example 3, 3, 4, and 5, they just say evaluate the function. And so then they tell you f of x is x minus 9, and they want you to find f of 3. So that means wherever you have an x, you're going to plug in a 3. So we're going to do 3 minus 9. Which happens to be -6. So that's your answer. So all they're doing is saying plug in a number, tell me what it equals. So number 4, you have your function f of x equals 2x minus 1, and they want you to find f of 4x. So everywhere we happen to see an x, we're going to plug in a 4x. So we're going to do 2 times 4x, because that's what we're replacing the x with, minus 1. Well, 2 times 4x is 8x. So this just becomes 8x minus 1. You can't do anything with that. You don't know what x equals. You can't solve. You're done. And then number 5 looks all weird because you have this function x squared minus 3x plus 2, and they want you to find g of -2 plus 5. So the first thing we're going to do is plug in -2. So we're going to do, and we're going to use parentheses because we have an exponent, so we're going to have to do -2 squared minus 3 times -2 plus 2, and we want to find out what that equals. My 2 got lost. So we're going to use our calculator or do your math, so you end up with -2 squared is 4. -3 times -2 becomes +6 plus 2, and if I add those all up, that becomes 12. So I know that g of -2 equals 12. Well, they want me to do g of -2 plus 5, so that means I've got to take 12 and add 5 to it, so my answer is 17. So you plug in your value and then do the plus or minus whatever they have tacked on to the end. So let's do one more example of evaluating. Number 6 looks a little different because it says evaluate the function f of x equals 5x minus 3. That's all good, but then they ask you and they give you this weird notation. It says 2 and then this brackets and then f of 3. Whenever you see something like this, we're going to work from the inside out. So what it says on the very inside is f of 3. So the first thing we're going to do is find f of 3. So we'll plug in our 3. And we get 5 times 3 is 15 minus 3 is 12. So f of 3 equals 12. And if I want to do 2 times f of 3, then I take that value and I multiply it by 2. So I do 2 times 12, which is 24. So that's the solution to that one. So you just plug in what it asks and then just do the operations. That's it. So now let's go back to number 2, that graph you had over in the first page. This is the same kind of problem, but now you have a graph instead of actually giving you the function. You just have a picture of it. So the first thing it asks for part A is, what is the value of f of 8? Well, so what we have done is we have taken f of x and we have replaced the x with an 8. So they're saying when x equals 8 on your graph, what does y equal? Well, there's that point right there, y equals 0. So f of 8 is equal to 0. The next one asks for f of 16. Same thing, go to where x is 16. It meets the graph right here. And if you look over on your y-axis, then f of 16 equals 12. Now C and D are backwards, because C and D now say for what value or values of x does f of x equal 4. So now they're saying, remember I told you that f of x is the same thing as y. They are saying y equals 4. So now what they're asking is when y equals 4, what values of x are there? Well, when y equals 4, it meets the graph here and here. So it's twice, this point and this point. And so I have two values of x, 4 and 12. So x equals 4 and x equals 12. D, it says for f of x equals 16. So now we want y equals 16. So that's this point right here, and it meets the graph twice, once here and once here. And we go see that's where x equals 18, and that's where x is 24. So my values are x equals 18 and x equals 24. And then E is interesting because E says for what values of x is f of x greater than or equal to 10. So they're saying when y is 10 or more. So right here is where the y value equals 10. And so if I draw a line all the way across, I can see what's above it and what's below it. We want to be equal to 10 or above it. So that's everything, all of this right here, every single point from here to here. So it's like finding the domain. All I want is the domain of just this section of my graph. And so there's an x value there, and there's your right x value over here. So this one on the left is between 14 and 16, so that's going to be 15. And the one way over here on the right is at 26. And so we write it just like we write a domain statement. So for the values of x where it's greater than or equal to 10 is everything between 15 and 26. So now is the graph of function. This is what you did today in class, what you practiced. You can use your vertical line test. You can look at x values and see, do any of them line up? Do you have any that repeat? If I do my vertical line test on this, there's never a place where it touches the graph more than once. So yes, this is a function because every x has only one y. And so now we got to do domain and range of the graph. So domain and range of the entire graph, not just this stuff up here. We want the whole thing. So we're going to go from left to right. So the far left point over here for the domain is at 0. And the far right point we already talked about was way over there at 26. And your range, remember, goes bottom to top. So the very bottom of that graph, again, is at 0. And up here at the top, it's at 20. So that's evaluating functions. You can do it from a graph. You just have to find the value on the graph that you've been given, or you just plug in the number. That's all it's asking for. So we will practice this tomorrow, and I will see you then.